All right, let's talk about a design pattern that can seriously crank up the performance of your Go applications. I'm talking about the prototype pattern. It's all about creating objects in a super efficient way, and trust me, by the end of this, you're going to see why cloning an object is often way better than building it from scratch.
So here's the plan. First, we'll look at a really common bottleneck, the repetitive build problem. Then, we'll introduce the prototype pattern as the solution. After that, we'll get our hands dirty with some actual Go code. And stick around for the last part because we're going to cover the gotchas and advanced stuff that'll save you a world of pain in production. Let's do it.
Okay, first up, the problem. We've all been there, right? That situation where your code is just building the same thing over and over, and it's starting to get really expensive.
So let's put this in perspective. Imagine your app has to spin up a default dashboard for every single new user. It's got to call a few services, hit the database. Let's say it takes 200 milliseconds. Now, for one user, no big deal. But what about 1,000 users signing up at once? 10,000? Now you're talking about a massive performance bottleneck. You're creating a digital traffic jam that can grind your whole system to a halt. And for what? To create the exact same dashboard every single time.
So how do we fix this mess? Well, the solution is surprisingly elegant, and it completely bypasses that entire build process. The core idea is incredibly simple. Copy, don't build.
The best way to think about this is like a photocopier. Seriously. You wouldn't redraw the company logo and letterhead from scratch every time you needed to send a memo, right? Of course not. You make one perfect master document. That's your prototype. Then you just hit copy to get a cheap, instant clone. After that, you can scribble whatever you want on the copy, the specific user's data, without ever messing with that pristine original.
And that's really the formal definition right there. The prototype pattern is all about cloning existing templates instead of building them from scratch. It's a classic engineering trade-off. You're trading a little bit of memory to hold on to that pre-built template, but in return, you're saving a ton of computation time, and believe me, it's a trade you'll want to make.
Okay, enough theory. Let's get our hands dirty and see what this actually looks like in Go. You might be surprised by how simple the code is.
Everything kicks off with this simple cloner interface. Think of this as our blueprint for a copy machine. It has one job, defined by the getClone method. You give it an ID for the template you want to copy, and it gives you back a fresh clone.
So where do those templates come from? Well, they're right here. These are just package-level variables. This is our master document tray in the photocopier. We create a white prototype and a black prototype just once when the application boots up, and they just sit there in memory waiting to be cloned.
And here it is. This one line is where all the magic happens. We have a pointer to our white prototype. That little asterisk there, that dereferences the pointer. It basically says, hey, don't give me the address, give me the actual thing at that address. And when you assign that thing to a new variable like new item, Go performs a value copy. Boom. You get a brand new independent shirt object in memory. It's that simple.
Now, this is an absolutely critical concept to grasp. We have two kinds of data. On the left, we have template data. This is the stuff that's the same for every single copy, like the price and the color. It lives in the prototype. On the right, we have instance data. This is the stuff that's unique to each clone, like its specific SKU. We only set this after we've made the copy. This separation is what makes the whole thing work.
Right, and this just drives that point home. It's a deliberate separation. You do the heavy lifting of setting up that common data once in the prototype. Then, for every clone, you're just doing the tiny, cheap job of setting the unique data. That's the secret to its speed.
And you know what's cool is how design patterns often play together. In this case, our prototypes, those package-level variables we made, are basically singletons, right? There's only one instance of white prototype for the whole application. This makes it a perfect, stable template for cloning. It's a really natural combination of two powerful patterns.
All right, you've got the basics. Now let's level up. We need to talk about the real-world stuff, starting with a massive pitfall. Seriously, this one thing can lead to some of the nastiest bugs if you're not paying attention. So, let me ask you a question. That simple copy we did, what do you think happens if our struct has a slice, or a map, or even just another pointer? This is where things get tricky, and it's where the simple approach falls apart. And this is the danger. By default, Go does what's called a shallow copy. Look at the diagram. When you copy the struct, it copies the pointer to the slice data, but not the slice data itself. So now, both your original prototype and your new clone are pointing to the exact same block of memory. If you change the data in the clone,
Surprise! You've just changed it in the original prototype too. You've corrupted your master template. The only way to fix this is to perform a deep copy. This means you can't just rely on the simple assignment. You have to manually create a brand new slice for your clone and then copy all the data over, element by element. As you can see, now the clone points to its own completely separate data. It's truly independent.
Okay, if you take away only one thing, let it be this. That simple new item equals star prototype line performs a shallow copy. Period. You have to look at your struct. If you see a slice, a map, or a pointer, a giant red flag needs to go up in your head. It is now your job to write the deep copy logic. If you don't, you're setting a trap for yourself that will cause bizarre, impossible to debug issues down the road.
So this brings up a good question. When do you use prototype versus, say, the builder pattern? It's pretty straightforward. Prototype is your go-to when you're just cloning a few standard templates. Builder is for when you need to construct a highly complex, unique object piece by piece. One is about copying what exists, the other is about building from scratch.
And just look at the difference in performance. It's not a small improvement. It's staggering. If your build cost is 100 milliseconds, but the clone cost is just 1 millisecond, you've just made that operation 100 times faster, a 100x speedup. In a high-traffic system, that isn't just nice, it's a total game changer.
But what if you need even more performance, like extreme high-throughput systems? Well, that's where you evolve this idea into using Go's sync.Pool. Instead of cloning a new object every time, you recycle old ones. You borrow an object from the pool, use it, and then return it. This completely eliminates the pressure of memory allocation and garbage collection. It's the pinnacle of object reuse.
All right, let's pull it all together. Here are the key things to remember. First, the prototype pattern trades CPU cycles for memory by cloning templates. Second, it's a huge performance win when object creation is expensive. Third, and I can't say this enough, beware of the shallow copy danger with slices, maps, and pointers. Fourth, use prototype for a few variants and use builder for complex one-off objects. And finally, for production-grade, high-speed work, sync.Pool is the ultimate evolution of this whole idea.
So I'll leave you with this one question to think about for your own code. Where do you have an expensive build hiding? Where are you paying a high price over and over again to create the same object? Because that spot right there, that's your perfect candidate for a clone. Go find it.